Welcome to Ascend, the unified data engineering platform for building and running autonomous pipelines. This video will provide you with an overview of how to ingest data into Redshift. To start, let's build a read connector, which is how we bring data into Ascend. We'll click on the Build tab, and we can see a variety of sources that Ascend supports, including all the common cloud blob storage providers and warehouses. We're building more read connectors all the time, but you always have the ability to create a custom Python to bring in any source that you may need. In this example, we're going to create an S3 connector. I'm going to provide it with a name. I'm going to give it the configuration location of the bucket, and I'm going to use a pattern to know where I go to get my data. We don't need any credentials here. Next, we'll tell Ascend how to parse this data. All the common formats are already handled. If your data is not in a standard format, you're never stuck in Ascend. You can also pick the parser function and write Python code necessary to deal with the data. In this case, we have some Parquet data. After selecting that, we can see that Ascend automatically generates the schema. The last step is selecting the refresh schedule. This schedule is not a naive pipeline run. Rather than saying when the pipeline should run, it dictates when to look for new data. On this schedule, Ascend will automatically look to see if any files are new, updated, or deleted, and only propagate those detected changes through the pipeline. We are going to choose an hourly schedule and look for it every 5 minutes after the hour. Let's hit save, and now we're done with our read connector. Ascend automatically starts bringing in the data, and we can even take a look at it. As you can see, it's brought in this data. We can even query the entirety of the data set, bringing the full power of SQL to exploring data as we're ingesting it. It seems that we don't have an ID for each of these taxicabs rides, so let's generate one. I've created some SQL here. Now let's run that. Now it looks like we have a good ride ID. Now we can remove the limit 100. And from here, we can click to transform. We'll provide it a name, and we'll click create. This transform is fully productionalized, regardless if it's thousands of records or billions of records. Ascend's intelligent partition and scaling will handle the rest. Although we can do transformations of your data in Redshift, Ascend transformations run on Spark. The difference makes it far more manageable to work with semi-structured data like JSON or also unstructured data. Additionally, you can use Python or Scala code, which allow for many more advanced use cases. The last part of our ingest to Redshift is, yes, writing this data out to Redshift. To do that, we'll create a write connector. As you can see, I have other write connectors, but for this example, we'll use Redshift. I need to configure it, so I'll give it a name. I need to choose the upstream data, the transformation that it came from. We're going to put it in Redshift. I'm going to give it a table name. I have a JDBC that points to our Redshift instance, and I have a role. And I'll choose my credential. We also have an S3 bucket that we're going to use. The next thing we need is a prefix. And we also need credentials for our S3 bucket. Ascend has the ability to do a few things. One is stop if there's a problem with the schema, but we also have the ability to alter the table and try to adapt to the schema changes. We can also do it with columns that mismatch as well. So now we're going to click Create, and you'll see that Ascend starts staging the data immediately. This allows us to make changes rapidly, like fixing types, adding additional columns in the SQL transform, and have it automatically materialized in the Redshift table. Note that Ascend automatically loads the data into Redshift incrementally by default to only bring in the most recent data. And that's it. We've built a production pipeline that will automatically keep data up to date, retry and failures, and notify upon irrecoverable issues.